Hi, everybody. My name is Mort Barlaz, and on November 19th, I gave a webinar as part of EREF Science session entitled A Deep Dive into Elevated Temperature Landfills. And there were many questions, and I was unable to cover all the questions in the allotted time. So this is, in essence, a supplementary recording in which I'm going to answer questions that were not addressed during the initial 1-hour session. I'll just start by reading the question and giving my thoughts as best I can. So the first question is global warming and climate change a possible cause for ETLFs? And my answer would be I really don't think so. Slight elevations in temperature might affect the surface and might affect on the order of 6 or 8 feet down into the landfill. And we're talking about even in the most severe impacts, a few degrees. I don't think climate change has anything to do with ETLFs. How would you suggest to interpret the indicator data differently at sites in arid regions where normal methane values are traditionally lower? That's a great question. So remember, instead of looking at the methane concentration, let's look at the methane to CO2 ratio, because when refuse decomposes, that ratio is going to be in the 50-50 to 60-40 methane CO2 range. And if you start getting out of that range, that's an indicator of a biological upset. So in other words, the concentrations of methane and carbon dioxide, even if you're making less, the relative ratio should be the same, irrespective of it being an arid landfill or not. In the finite element model, why is there such a large anomaly in the temperature gradient when comparing hydration plus carbonation to carbonation only? So I'm gonna go to a slide and let's take a look at that. And I'm not gonna share so I'm thinking that the question is referring to this slide. And I'm not actually sure what you're referring to in terms of a large anomaly in the temperature gradient. The key point here is that when you have a carbonation only, meaning hydration occurred outside of the landfill, you're generating less heat, so the peak temperature is going to be lower. And the black dotted line is simply the location of the column of ash that was disposed. Has there been any research done on shear strength? Among other limitations, I do not have a geotechnical background and cannot speak to geotechnical properties such as shear strength. The next question, do you think geophysics plays a role in ETLF surveys? What type of geophysics tomography is effective? And they're talking about thermal infrared imaging, electrical resistivity, thermal monitoring. I'm not an expert on geophysical monitoring, so I can't really say. I can say that, again, remember these impacts tend to be rather deep, not in the top 20 or 30 feet or even 50 feet in general. So I'm just not sure if geophysical imaging would be helpful. Do state regulations put limitations on ETLFs? To my knowledge, regulations don't regulate ETLFs specifically, but they regulate the temperature of landfill gas. They regulate their regulations on how much SOx can be emitted, and we're seeing elevated concentrations of dimethyl sulfide at many ETLFs, and that translates to elevated SOx. So what I do see are there very, very definitely regulatory challenges, but they're within existing regulations and they apply whether it's an ETLF or not. Now, suffice it to say, regulators are interested and want to know that things are being managed properly, but it's under the guise of landfills and not specific to ETLFs. Any recommendations on shears testing? I really don't. You indicated that depth is a risk factor for developing an ETLF. Is there an industry accepted best management practice for maximum depth or surface to area ratio? I do not know of an industry accepted best management practice, and I can't stress enough, we've got lots of deep landfills that are not ETLFs. So as indicated in the question, it's a risk factor, but it is not a sure thing. What I would say is if you have a site that has, for example, a high surface area, excuse me, a low surface area to volume ratio, such as a quarry with very steep sidewalls, that's when I would be extra attentive. It's a risk factor. It doesn't mean it's going to happen, but it's absolutely a case where let's be extra vigilant in our monitoring, not just gas composition and temperature, but also liquid levels. In a reaction where your well is inverted, so the methane to CO2 is less than 1, and the vast majority of the balanced gas is hydrogen, can this be an exothermic reaction derived from ash or aluminum? It can be, yes. When aluminum, so there's two sources of hydrogen. When aluminum corrodes under anaerobic conditions, hydrogen is a byproduct. Hydrogen is also a byproduct of the normal waste decomposition process when cellulose or MSW is converted to methane. In an ETLF, the organisms, specifically the methane-generating microorganisms that would normally consume hydrogen, are inhibited. And that is why the hydrogen accumulates. So the production of hydrogen in a landfill is quite normal. What's abnormal is in an ETLF, the consumption of that hydrogen is inhibited, and that's why it accumulates. Whether that's accumulating due to aluminum corrosion or whether it is due to an interruption of the cycle of cellulose conversion to methane, I can't differentiate the two, but it could just be interruption of the cycle. I don't know of a scenario where hydrogen would be generated from ash unless that ash has some aluminum in it. In case of landfills with increased temperature, is there an opportunity to use that energy somehow? Theoretically, yes. Practically, no. You know, and there is a paper by a group. I think it's at San Diego State, but I can't promise. It might be University of San Diego, where they looked at heat recovery from landfills. But remember, again, you don't know you have an ETLF until you have it, and at that point, there can be 50 to 100 feet of waste on top of it. So the idea that you're going to drill in, put in pipes, and then have a source for that fairly low-grade heat, you know, thermodynamically possible, but practically there's just not much feasibility because of the amount of heat and where you could possibly use it. Is use of wood ash to solidify sludges that are then incorporated into MSW perhaps a factor that create an LTLF? Well, tell me the calcium content of the wood ash. It's not about ash, it's about hydration and carbonation reactions. So if that wood ash is elevated in calcium, it can absolutely contribute to elevated temperatures. particularly if we're starting with calcium oxide. Can ETLFs cause fires even if they're not the same thing? I don't think so. There may be cases where they do, but not that I can think of. The key point is you need oxygen for a fire. And these ETLFs tend to be at depth. So what's the mechanism? If you had a lot of heat at depth and it diffused, or not diffused, but was transported up by conduction, and then you got so hot that you got spontaneous temperatures high enough to support spontaneous combustion where there's oxygen, theoretically maybe, but I don't see that as likely, and I've never heard of an instance where that's been the case. As I say, the ETLFs tend to be quite deep and there's not oxygen there. Do ETFs in wells cause the leachate to foam? I have not heard of an instance where that has occurred. Yeah, I'll leave it at that. I can give you a theoretical explanation of why it might be an issue, but I just haven't heard of it, so I think we should just leave it at that. How important is it to get HOVs to allow gas extraction? It's 100% critical important. Remember that slide I showed? I'll go back to it if I can get there quickly. I'm going to share my screen again. So here's this top plot is the gas temperature. Here's a case where they were made, the landfill was made to turn off the well because they didn't have an HOV. When they turned it on, the temperature shot way up, the methane to CO2 went way down. You absolutely want to get the gas out, so you need permission to do that. You do not want to turn off the well. Where are we? How much water is attributable to the reaction products? Volume per ton of waste reacted. I don't know. I don't think that the reactions are defined well enough that we can quantitatively answer that question. What I can say is the ash hydration reaction consumes water. The corrosion reaction consumes water. The hydrolysis reaction, I don't know that it's generating water. I think that the major water accumulation is not reaction products. What it may be is if you have the existing an existing waste mass and some of that waste mass is converted from solids to gas, and then you have less solids to hold the liquid. And I tend to think that's probably more important. Does an ETLF spread faster under a final cap? Well, I kind of doubt it, only because, yes, to be sure, a final cap reduces heat release from the surface of the landfill. That's true. But again, the temperatures tend to be quite deep. And if you have an ETLF, you might be installing the final cover to improve gas collection and improve odor control. But at that point, you're also pulling a lot of heat from the landfill. So I would be surprised if putting a final cap on is exacerbating heat accumulation. And I would absolutely, if it's time to cap it, I would cap it. Now, the other thing I will say is if you're still experiencing a lot of settlement, that's not the time to put on a final cap because you'll damage it. Are ETLFs a relatively new phenomenon? I think the first one we recognized was 2008 or so, countywide in Ohio. So that's 16 years. I'm old enough. I'll say that's recent, but depends on your perspective, I guess. If you're in your 30s, that might seem like ancient history. Advice on educating regulators on ETLFs so we can stop misregulation. Well, that's why I did this seminar. Um, I love the fact that EREF is willing to sponsor these and do them for free so that anybody can watch, make it available so that people can go back later. It's published on EREF's YouTube channel. So I can't, my advice is, in all fairness, a lot of people in the regulatory community, they don't have travel budgets, so they don't get to go to conferences where they can learn the state of the art. They're probably not reading journal articles, and even if they are, they're hard to interpret in the context of field sites. So, or some are. So, I think the best we can do is accumulate sources of information that we're comfortable with that are readily accessible. And at least from my perspective, this science session is one of them, and that's what motivated me to do it. What's the best data a landfill should provide for an HOV request to convey the landfill behavior as an ETLF versus a subsurface event? So, in other words, if you're experiencing elevated temperatures, but you want to keep pumping gas, and a regulatory body is saying no, stop, the data that I would give them, number one, might be that picture I showed you where the temperature shot up after a well was turned off and turned back on, number one. But more generally, I would show them gas composition data that shows that there's not an accumulation of oxygen to prove or make them comfortable that this is not a fire. Because the concern is if it is a fire, you don't want to pull gas. So I would start with that. And I would also ask what they would like to see. You know, anytime you're having a discussion with someone, if you can try to understand what they want, often that's helpful. But I would start by convincing them that there's no air intrusion. Leachate recirculation was popular in the past. Could that practice make a site more likely? I doubt it, but there may be exceptions to that. To be clear, if leachate was recirculated with no controls on how wet the waste was getting, and a lot of perched water was left in the site, yes, that would impact gas removal from flooded wells, and it would impact heat conduction. So I wouldn't say it's a bioreactor that caused it. I would say if that operation as a bioreactor led to a lot of perched water, that is a contributing factor. Not the only one, but a contributing factor. Health impacts in the area that have elevated temperatures, any studies, or does that need to happen? I'm not aware of any health impacts, and at least in my mind, and I'm not an epidemiologist and I'm not an air quality expert, but by the time the odors migrate off site, they are so dilute that in most cases, I would be surprised if there is a potential health impact. But to my knowledge, there haven't been studies, and I would start by wanting to quantify concentrations of volatile organics at the site boundary and see how they compare to any standard. Why do some landfills show excess N2? O2 does not appear to be consumed. This is a question that's actually bugging me quite a bit. And you'll notice in my slides, I said something along the lines of nitrogen is not well understood. There's two possible explanations. Explanation one is you're drawing in air, and as you draw in air, the oxygen is consumed, but the nitrogen is conservative, and that would give you nitrogen in the gas. And the other explanation is that nitrogen is being produced. I cannot, the only reaction that I know of that produces nitrogen would be nitrogen gas, would be nitrate reduction. And it's hard for me to imagine that there's enough nitrate in the waste to generate high quantities of nitrogen gas. I've talked to operators who are assuring me they don't have air intrusion and they think they're generating N2 gas. And that is a mechanism that, in my mind, needs further study. I've actually got an idea for how to do it with stable isotopes, and probably gonna push that a little bit because it's a question that keeps coming up. One thing a landfill recently mentioned as a potential indicator was dimethyl sulfide. Any information? Yeah, I would classify dimethyl sulfide as a lagging indicator, not an early indicator, not a leading indicator. Two reasons for that. The boiling point of dimethyl sulfide is 99 degrees Fahrenheit. So as you heat up, you're converting more from the liquid to the gas, but that makes it a lagging indicator. The other possibility or the other mechanism is food waste contains reduced sulfur. As the food waste degrades, dimethyl sulfide is generated, but it is when the methanogens are healthy, that dimethyl sulfide is consumed. It's converted to H2S, methane, and methyl mercaptan. So I think I have a decent understanding of dimethyl sulfide or DMS cycling in the landfill. It is an indicator, but it's a lagging indicator. The longest and shortest time frame you have seen an ETLF burn. So let's delete the word burn from that question, because burn means fire, fire means oxygen. That's not an ETLF. And the longer answer is I don't know. I was at a site 10 years later and the solids were still hot. But I can't give you numbers because I don't have enough information on either the longest or shortest time frame. Tips for regulator education, I think we've covered that. Best way to correct a chemically reactive waste that previously recirculated leachate with elevated temperatures. I'm not really sure I understand the question. The best way to correct implies that the chemically reactive waste was already buried. And if it was already buried, then I want to know what the waste is. If it's aluminum, then I want to keep ash away from it because it's alkaline. If it's ash, the drier the better, but you're still going to have carbonation. So once it's buried, the best thing might be to monitor and remove as much heat as you can and try to keep that area dry. How should new EPA regulations be changed to address ETLFs? Actually don't think we need more regulations for two reasons. Number one, if an owner has an ETLF, it's costing them tens to hundreds of millions of dollars to manage and contain that ETLF. Given those kinds of costs, I don't know that they need any regulatory incentive. Second, One of the things I tried to stress in the presentation was that each ETLF is unique. And if you have unique site-specific considerations, then a one-size-fits-all approach, which is what regulatory bodies tend to do, is they write something and apply it to everyone. It's likely not to be very effective at a specific site. What I would rather like to see is if a site is in an ETLF condition, sit down with the regulators and acknowledge, hey, look, we have a problem. We recognize the problem. Here's what we're doing to manage the problem. And just be totally transparent and have a dialogue. I don't feel like a adversarial relationship. From what I can see, all it does is slow down the actions that need to happen. And frankly, the operators, in my mind, have a better sense of what needs to happen than somebody that's not an operator. And that's not an insult to regulators. It's just the operators are there every day. They've got as much incentive as anybody to manage it. So I don't actually feel like we need more regulation. Now, you could say, what about public sector landfills where there's not a profit motive? Do they have less financial incentive? I don't know. I don't know. If you're operating a landfill, you need to act responsibly, whether there's a financial incentive or not. But I'm not sure how regulations can help. The one idea I will float is I see huge amounts of data being collected. I see less data being reviewed. I see operating reports with 100 pages of well-by-well lab analysis. What I really want is a spatial distribution of the methane to CO2 ratio by well, or trends in time that show me how's the methane to CO2 ratio changing with time? How's the temperature changing with time? So I would love to see more standard formats for how data are presented in operating reports, whether they go to a regulator or whether they're used for internal review. We need to look at the data graphically. I don't think paging through hundreds of pages of lab reports is effective. Are there leachate reduction strategies for ETLFs? Well, there are leachate reduction strategies for all landfills. If you have perched water, you need to be pumping it out. And that, in the case of an ETLF, means pumps and wells. And those wells, those pumps need to be able to handle high temperature. If it's not an ETLF, there's lots of best management practices to reduce leachate. And let's start with good cover. I've been to a site where they were using a sandy intermediate cover. The wells were flooded and the gas control was weak. They shouldn't be using use an intermediate cover that reduces infiltration, not sand. Has the presence of ETLFs in the industry had an impact on best management practices for bioreactor landfills? I actually think there are best management practices for bioreactor landfills that were developed before ETLFs. And simply watch your moisture content. If some water is good or some leachate is good, that does not mean that more is better. And where bioreactors have had problems is where they put in too much water and wells have flooded, and then gas collection decreases, increases fugitive emissions, and causes an expense possibly to put pumps in wells. So I think some water is good, too much is bad, and do some rough estimates of how many inches of infiltration are you getting, how much waste do you have. Keep the moisture content maybe to 35% or lower. That's enough for biological activity, but not so much you're likely to see flooded wells. But in parallel, monitor the liquid level in the wells. And if you see accumulation, jump on it. That's when you need to start pumping it out. Do ETLFs occur in large landfills more often than small landfills? The sites that I've seen are all relatively large, but I can't stress enough there are lots of large landfills that are not ETLFs. I do not think that regulating landfill size is a good strategy. I think that going forward, owners are very attentive to not letting heat accumulate. So yes, they occur more. From what I've seen, they occur more in large landfills than small landfills. I don't have quantitative data on that, but I would stress that there are lots of large landfills that are not hot, and so let's focus on the operation practices we've talked about and the monitoring practice we've talked about, and not, in my mind, go off on a tangent on large landfills as something to be avoided. And don't forget, and I'll conclude with this, landfills are part of the municipal waste management infrastructure. We cannot manage solid waste in this country at this time without landfills. So if you start going down the road of, oh, large landfills aren't good, that translates into more small landfills. And we all know that siting landfills is hard, et cetera, et cetera. So please, consider second order effects and consequences. It's not just all about size of landfill. Okay, with that concludes the questions that were submitted. I sincerely hope that this was useful. And again, the original recording is also available on EREF's YouTube channel. And thank you for your interest.